Alright, so now we're going to go ahead and look at some variable valve timing stuff on this Hyundai, and I'm not going to lie, I already jumped the gun. I got this sensor unplugged, I got it probed, and I'll show you what we read in a second. But if we come over here, we'll just look at a little bit of general description about the variable valve timing system. So it says, it talks about, you know, oil flow, controls the actuation, it regulates the camshaft angle relative to the sprocket, so it changes the clocking between the sprocket and the camshaft. So yeah, engine torque, fuel economy, and exhaust emissions decreases. So that's generally the description of that. So let's get to look and see what all we got from that. Here's kind of a better explanation of the way it works. So you have this cam gear that bolts onto your cam, and this is what they call the CVVT assembly. So, you know, the actual thing that varies the valve timing. And then on these cams, so you have oil that's fed into the you have oil that's either fed one way into one side or the other side, and it either advances the timing further from its stop position, from its standard position, it advances it further if oil is pushed into the advance hole, or it retards the timing if from its standard position if oil is fed into if pressurized oil is fed into the retarder hole. So out on the car here, like I just saw, we have this connector to the intake side variable valve timing solenoid. This does have variable valve timing on both cams, intake and exhaust. And this is the solenoid that controls that. The solenoid that controls the rear bank is right there, and that's the connector for it. If we check out the wiring diagram here, you can see that oil control valve, they call it, that we're looking at. And then it has two wires, your white and orange, comes over here and goes to this fuse, sensor 2 fuse under the hood. So that's power. And then this one, brown wire, goes down to the PCM. So that is your signal wire. So let's look at those on the car real quick. All right, well, we got this sensor unplugged, and as you can see, we've got a brown that goes to the PCM, and you've got a white and orange, so that's power all the time. So let's check those with the meter and see what we got. All right, so right now we've got the meter connected. I know there's a lot of wires, but from that white and orange wire through this side to the red clamp, to the meter, and to ground. And on the meter, we have 12 volts. So we can confirm that this is getting power all the time, even though the ignition's on, and that means it's ground side driven. So now with the meter hooked up to both wires, the positive and the control side, the signal side, we have 8.41 volts, which I'll show you on the meter. Looks like a nice 8.41 volts. But we also have the Picoscope hooked up to this. You can see that clearly the meter is showing an average, because we do have a little bit of a waveform here. So let's look into that and see what all we have here. All right, so now we're back probed in between the signal wire and ground on the engine block. So you can see we have 12 volts. So I got Miles on the key over there. Hey Miles, start it up. Zoom in on that a little bit. So there you can see a solenoid actuating, because we were going from up to 12 volts. Here we have, and I think it's kind of clear in this one, it looks like there's a voltage spike there up to about 15 volts. Alright, so let's see what happens when you give it some gas. Increase the engine RPM, it should show a change. Yeah, so there you can see it changes the pulse width of that. To allow more oil to flow through the camshaft to advance the timing. So now we're going to take a look at the cam system on this Chevy Colorado. This variable valve timing system is a little bit different, and I'll show you why. So there's a lot going on up here, as you can tell. This is a 4-cylinder engine, so you've got coil packs here in the middle. 1, 2, 3, and 4. They're kind of hard to see. And then on either side, on each, so it's a dual overhead cam engine. Here's your intake, and your exhaust is back there. On each, over top of each set of valves, you have a valve lift actuator. So here, 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 and here, and same on the other side of that row of coils. So it's pretty confusing. Let me go look at all data and I'll tell you guys how this works. So here's kind of a little bit of a chart to explain on the Colorado how, what it's going to want from each scenario with regards to valve timing. But it talks about, it's controlled by ECM, whatever, inputs and outputs. It talks about, so let's see, oil fills the advance or retard chambers and then vents oil from the opposite chambers, which produces a torque on the actuator rotor. So that's the same as the Hyundai. It's going to push that cam gear one way or another with reference to the camshaft position. And then this is the interesting one. So they call it the sliding camshaft valve lift system, the SCS system. So it uses these sensors, and it's got 3 different modes. So it can give it high lift for full power, low lift for economy, and then surprisingly enough, this engine has AFM on a 4-cylinder, so it shuts off cylinders 2 and 3. So it'll run on 2 cylinders. I'm sure that's good for the engine life. But here's kind of what we were looking at a minute ago. You've got 1, 2, 3, and 4 on the intake, and then just these 2 on the exhaust. So here's what the cams look like, and you can see, looks like that slides it back and forth to change it from one cam profile height to another. So that's what that's going to look like. Isn't that complicated?
Okay, we're in the Chevy right now, and here we have our intake camshaft position actuator. Position, you can command what state it's in. So right now the car is kind of idling normally, a little like under 1,000, about 700-ish. And so if we increase the intake cam position, you can see the RPMs increase to 1,000. And you can see the degrees here. So if we release control, you can see the degrees kind of drop of what the desired position is and what it actually is. So we increase it, decrease it to 0.7, increase it some more, and it goes up a little bit. And it'll just keep going up as you increase the commanded state. So now we're going to give it some revs. So right now the commanded state is none. So it's at the normal, what it should be at. So we rev it a little bit. We'll see the intake cam position increase to about 12 degrees. And then, so if we increase the commanded state to 2 degrees, see it drops. And it doesn't really change much when we increase RPMs. We're now about 2,500, and then it goes to 12 degrees. And we increase it a little bit more. So you see the numbers jump up. RPMs a little above 1,000. Bring it back to 2,000 RPMs. We'll see it's at about 10-11 degrees. And so it's a little bit less than when it was at 2 degrees. Good. So here we're at the Colorado wiring diagram. Here we have the intake cam profile sleeve, the position sensor 1. So this is a 3-wire sensor. The violet and white wire, a black and green one, and a white and red one. This violet and white one, this is going to go to the cam intake lobe axial position signal 1 pin over in the ECM. This white and red, that's going to be the 5-volt reference signal, and the black and green, that's going to be your low ref. Alright, so now we're over here with the intake camshaft profile actuator 1. So this is a lot of wires, but we're just going to focus on these ones right here. So this blue and white one is going to be your camshaft monitor position sensor 1 signal. This black and yellow one is going to be your ground. Blue and red is going to be your 5-volt reference. This green and black, it's going to be the step cam B control. This violet and blue is going to be a 12-volt from fuse F25. And this violet and gray wire is going to be your step cam A control.
So here I'm tapped into, we've got the truck running, and I'm tapped into the signal wire of the camshaft sliding valve lift actuator sensor. So it should detect the position of that sleeve, whether it's in low profile cam mode or high profile for the more performance. But the signal we got from that is kind of disappointing. So, hey, can you rev it? It just looks like a cam position sensor signal. It looks like about the signal you'd get out of something like a Hall effect sensor. So that's a little disappointing, but I tried tapping into the monitor wire from the camshaft position the camshaft lift sleeve actuator. It has a monitor wire on it, and all I got back from that was about the same reading as this. So I don't know if I don't know how to read it correctly or what. I'll have to talk to Mr. Ragnes about that. Alright, so here if you look, we're pulled into the this is the data we came up with. So it's a 3-wire sensor, so it's a Hall effect sensor, I believe. And there you can see all the teeth, and then there's the gap. So if you count, that's 37 teeth minus, well, 38 teeth minus 1 gives you 37 teeth with the gap right there. All right, now we're wired up to the cam and the crank sensor. So the cam sensor is what you see in the red, and the crank sensor is what you see in blue. And if we stop that for a second, you can see there is one rotation of the crank right there, because you have your space there, your 37 teeth, and then the space here. And then this is basically got a couple unique looking teeth. And it's bouncing between right at 0.9 volts and 5 volts. So here we've got 2 full rotations of the crank on the screen. So here's start of one, end of one, start of one, end of the next. So you can see for this timing, this cam position sensor signal looks completely different for one rotation than it does for the next rotation. So then the rotation after this will go back to looking like this. So that way it can tell which cylinder is at top dead center.